This lesson is on reducing fractions, and I'm going to start off this lesson with a very simple question. Jack and Jill both ordered large pizzas that were equal size, but from two different pizzerias. Jack ate 2 slices of his pizza, and Jill ate 1 slice of hers. So here's my very simple question. Who ate more pizza? You know the answer to this, right? You're confident? You know what it is? Well, let's take a look. Make sure that you're right. Take a look at these pizzas. Jack ate 2 slices. Jill ate 1. Now, after looking at this, you could see, well, yeah, Jill really did eat more pizza than Jack. It's because it's the way they were sliced. You can describe the way a part of a whole with what's called a fraction. That's the whole point of a fraction, is a part of a whole. And the 2 numbers that you see on fractions, the top and the bottom number, one's called a numerator and the other's called the denominator. That's the name of the top and the bottom. Numerator. And the bottom number is called the denominator. The numerator describes how many slices do you have or did you eat, but the bottom number describes how many slices make up that whole. So that's why Jack ate 2 of his slices, but there's 8 slices altogether that makes the 1 whole pizza. So you can describe his pizza as 2 eighths. Jill ate just 1 of her 2 slices, so that's why Jill ate 1/2. Now there are other ways to describe the same quantity of either pizza. Let's take a look at Jill's pizza again. I think you would all agree this question would be fair if both pizzas were sliced exactly the same. So let's slice Jill's pizza in the same way that Jack's pizza is sliced. But let's keep in mind, we're still going to say she ate this much pizza right here. Alright, so let me slice her pizza the same way Jack's pizza's been sliced. So it's been sliced down the middle. Oops, didn't do it, just a second. Here we go, sliced down the middle there, it was sliced this way. So if we slice her pizza into 8 equal slices, sorry that last line was just a little off, but you get the idea. How many slices did she eat compared to Jack's now? Well, it looks like she ate 4 of the 8 altogether. That's the only real way to compare 2 fractions to see which is bigger or smaller. So you have to have the pizza sliced the same way. They're called common denominators. We're going to have another lesson on common denominators, but right now we need to talk about how we can describe a pizza or describe a fraction without much work or the fewest amount of slices possible. Just a second. So let's look at another piece of pizza. Let's pretend that Jack had another piece of pizza and he wants to eat the exact amount he ate, let's say, the day before. So here's what he ate the day before, those 2 slices up there. Well, with this new pizza game, how would you eat the exact same amount? Well, we can see it pretty easy here. That amount right there. What fraction of that pizza represents the exact same amount? I think the top number is 1 for his 1 slice, and what would the bottom number then be? 4th, your denominator 4th. So we would have to eat 1/4 of that pizza. Notice our numbers of our fraction are getting smaller and smaller, but we're still talking about the exact same amount. That's exactly what you're trying to do when you're reducing fractions. You're trying to use the smallest amount of cuts possible, the fewest amount of slices to describe the exact same amount of area. So the way you will do this is you need to divide the top and the bottom of any fraction by each number's greatest common factor. So you did this in the previous lesson. That's why I said we were gearing up for this. So let's find the greatest common factor of 12 and 28. Well, all the factors of 12 are 1 and 12, 2 and 6, and 3 and 4. There's no more numbers between 3 and 4, so I know I'm done. I have them all down. The factor pairs of 28 are, of course, 1 and 28, 2 and 14, 3 doesn't go into 8, 4 does, 4 and 7, and there's no other numbers between 4 and 7 that go into 28. Oh, what is it? Am I missing? Yeah, no, that's it. I keep on questioning myself if I'm missing any, but that's it. So what is the greatest common factor? We have common factors, right? We know 1, 2, both going to, but the greatest common factor is the 4. So this is what you can do with your greatest common factor. You can use it to reduce a fraction all the way to its lowest terms. If we take 12 and divide it by 4, you get 3. And if you take 28 and you divide it by 4, you get 7. So another way to describe the fraction 12 over 28 is 3/7. Now, if any of you have worked with fractions before, you may have done reducing and not known to use the greatest common factor. And here's what happens if you don't use the greatest common factor. I'm going to look at the numbers 12 and 28. If I didn't write those factor pairs to really make sure that I'm using the greatest common factor, you might have identified that 2 went into both numbers. If you divide both numbers by 2, though, you would get 6 over 14. There are still numbers that you can divide both the top and the bottom by, so that means 6 over 14 is not reduced all the way to its lowest term. You would have to then reduce again. 6 and 14, if you thought, oh, I can divide those both by 2, half of 6 is 3 and half of 6 is 7. So you may not always catch that you have the lowest terms, or that you need to break, or that you have to keep on going. You're actually going to create yourself some more work. By also creating your factor pairs, watch what really cool thing happens. Notice I circled the 4s on each one of those factor pairs, and I told you before I really like it when you write it as factor pairs. Look what numbers are right beside the greatest common factor. Do you see the 3 and the 7? That's right. If you write factor pairs of any fraction and find the greatest common factor, the reduced fraction will always be sitting right beside the greatest common factor. Let's try it with some practice problems. Okay, so on your practice page that you should have in your binder, you have an example problem there, 8/16, and they reduced it all the way down to 1/2. Let's prove how they got that answer. Now, you're not going to have a whole lot of room on your page, just like I don't have a whole lot of room on the screen. I'm going to go ahead and write 8 and 16 just for us to remember what are the two numbers we're trying to find the greatest common factor of. And I'm going to go to my whiteboard, so you might want to get a scrap sheet of paper out to actually work these problems, because there's just really not enough room. Right? I'm going to go to my... So here are the two numbers that we're trying to find the reduced fraction for, 8 and 16. We need to first find the greatest common factor between 8 and 16. So let's write all the factor pairs of 8. 1 and 8, 2 and 4, and there's no numbers between 2 and 4 that go into 8, so I'm done with the 8. Let's look at 16. 1 and 16, 2 and 8, 3 doesn't go into 16, but 4 does, 4 times 4. And there's no numbers between 4 or 4, so we're done with 16. Therefore, your greatest common factor between both numbers is 8. And we can find out with the reduced fraction, 8 over 16 is equal to by looking at the numbers right beside the greatest common factor. So next to the 8 is a 1, and next to the 8 on the 16 is the 2. That means 8 over 16 equals 1/2. Let's see if that's what we got for the example problem. And it is. You have the number 1, or you have the fraction 1/2. I'll do another one for you, but then I really do want to leave the whole rest of the page for you to practice these, and then you can self-check and correct your work. But it is good to get lots of practice on reducing fractions and making sure that you do get all your fractions reduced all the way. So I'm going to do the next one for you, 21 over 30. So I'm going to write my 21 and my 30. So I'm trying to reduce that fraction, 21 over 30. Find out what it equals to. I'm going to go to my whiteboard so that you can actually see what I'm doing. Factors of 21 are 1 and 21. 2 won't go into it because 21 is not an even number. 3 and 7. And that's it. There's no numbers in between 3 and 7 that go into 21. For 30, the factors are 1 and 30, 2 and 15, 3 and 10. And if you are not that fast writing all these factor pairs, that's why you're working on your fast math with division, so you start remembering all your facts and you can do these quite quickly. Say 3, 4, 5. Yeah, 5 and 6. 5 times 6 equals 30. And there's no numbers between 5 and 6. So our greatest common factor of 21 and 30 appears to be 3. And we look right beside the greatest common factor, and there's our reduced fraction, 7 over 10. And we're done. Okay, try the rest of this page for practice, and then go to your self-check and correct to fix any mistakes that you make before you take your quiz on reducing fractions. Good luck.